Let me ask you a question. How can voltage be present in a circuit, but the current is zero? Take a look at this screen. Voltage is 1.68 volts. Current is 0.00 amps. Power is 0.00 watts. Status says no supply. If voltage is present, why is nothing actually working? This single situation causes a lot of confusion in electrical work, and it is one of the biggest reasons why faults are misdiagnosed. Most people are taught one simple idea. If there is voltage, then the circuit is alive. But that idea is incomplete, and in some situations, it can be dangerous. In this video, I want to slow things down and explain why voltage alone is not enough, and why current is the real diagnostic tool. I am not going to explain this with theory alone. I will use a real experiment so you can see it for yourself. To demonstrate this, I built a simple diagnostic system that measures voltage, current, and power at the same time. Instead of guessing what is wrong, the system shows what is really happening. Let me walk you through the components I used. First is this 20x4 LCD with an I2C backpack. I chose a 20x4 display because it allows me to show more information at once. On this screen, I can display voltage, current, power, and system status clearly. The I2C backpack reduces wiring. Next is the ESP32. This is the brain of the system. The ESP32 reads the data, processes it, and sends results to the display. Then we have the most important part, the INA219 DC voltage and current sensor. This sensor does something very important. It measures actual current flowing, not just voltage. This is the component that allows us to see the difference between a circuit that looks alive and a circuit that is actually working. I am using a full-size breadboard to prototype the circuit. It helps keep everything organized. I also used some jumper wires to connect the components together. For the load, I am using a 12-volt power bank. This is a real device that draws current, so it is perfect for this experiment. The ESP32 is powered using a 5-volt Type-C cable. And finally, I am using a 12-volt 2-amp adapter as the main power source for the load. Now let me explain the connections. The positive output of the 12-volt adapter goes into the input of the INA219 sensor. From the output of the sensor, the power goes to the load. This is very important because it ensures that any current flowing to the load must pass through the sensor. There is no way for current to bypass the measurement. The ESP32 connects to the INA219 and the LCD using the I2C lines SDA and SCL. Only 2 wires are needed, keeping it simple. After completing all the connections, I plug in the 12-volt adapter. Then I upload the code using the Arduino IDE. At first, the LCD does not display anything. This is normal in real engineering work. Things do not always work the first time. I had to troubleshoot. I checked power connections, confirmed the I2C address, adjusted contrast, and stabilized the sensor. After fixing these issues and updating the code, everything starts working properly. Now, we get to the most important part. Look at the display. Voltage is present, 1.68 volts, but the current is 0. Because current is 0, power is 0. No energy is being delivered. Even though voltage is present, the circuit is not doing any work. This is where many people get confused. Voltage by itself is just electrical pressure. Pressure alone does not make anything happen. Current is the movement of charges. Without movement, there is no work being done. That is why current is such a powerful diagnostic tool. This happens in real life. A broken wire, an open switch, a loose terminal, a burnt contact. Or you could be measuring phantom voltage. In all these cases, your meter might show voltage, but nothing works. This experiment makes that invisible problem visible. Now here is the final takeaway. Voltage tells you something might work. It shows potential. Current tells you if it is actually working. Current shows reality. Power confirms that useful energy is being delivered. If you only measure voltage, you can easily be misled. If you measure current and power, you understand the real condition. That is the purpose of this experiment. If this changed how you think, you are thinking like an engineer. Like and subscribe.